Yesterday we started about the magnetic quantum number. Now I will explain about the one example with the magnetic quantum number with one example. Actually, for magnetic quantum number value for m, the m value for S subshell 0. Okay, I will explain now with example. For example, the magnetic quantum number, the m, it depends on L, and these values will be taken as plus L to minus L to plus L including 0, minus L to plus L including 0. So here, for example, if n is equal to 1, if n is equal to 1 and its azimuthal quantum number value, the L is equal to 0 only. Ikkada 1 unte ikkada kuda 1 value unte, that value is 0. And if it is L is equal to 0, the m value also 0 only. Because of minus 0 plus 0, minus 0, 0 plus 0 will not possible. And here this is S subshell, and obviously this one is S orbital. S orbital. Okay. And for example, if you take n is equal to 2, the second shell, for second shell, the azimuthal quantum number value L is equal to 0 and angular momentum quantum number value 1. The maximum L values are n minus 1. The maximum L values are n minus 1. If it is L is equal to 0, the magnetic quantum number also 0 only. That is S orbital. And that too 2 orbital, 2s orbital. This one S subshell, we know that one already. And here this is P subshell. And the one, when azimuthal quantum number value 1, the magnetic quantum number value will taken as minus 1, 0, plus 1. That means it's having 3 orbitals. It's having 3 orbitals, right? These 3 orbitals in this minus 1. That's why this is p orbital. For example, if n is equal to 4, Nana, if it is n is equal to 4, how many the maximum L values? The maximum L values are 4. L is equal to 0, L is equal to 1, and if it is L is equal to 2, and L is equal to 3. Okay. And if it is L is equal to 0, the M value also 0 only, and that is S orbital. Obviously, this is S subshell, P subshell, and D subshell, and F subshell. Here I will explain. This tells about this azimuthal quantum number tells about the S subshell. Subshell ante okate subshell untadi, that is S. In this contains only one orbital, that is S orbital. Actually, S has only one orbital, and P has 3 orbitals, and D has 5 orbitals, and F has 7 orbitals. Seven orbitals. So that means here, when L is equal to 1, the magnetic quantum number value minus 1, 0, plus 1. That means here minus 1, 1 orbital, and 0, 1 orbital, plus 1, 1 orbital. How many orbitals are there? 3. 3 orbitals dentlo untayi p orbital. And here if it is L is equal to 2, what about the magnetic quantum number values? Minus 2, minus 1, 0, plus 1, plus 2. How many orbitals are there here? Here, this is minus 2, minus 1, 0, plus 1, plus 2. Okay. And next, if it is L is equal to 3, what about the magnetic quantum number values? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Okay. That means here 7 orbitals. 1, 2, 3, 4, 5, 6, 7. So this is F orbital. Is it clear? I will give shape of the orbitals. There will get the clarity. I am going to remove this one. After giving shape of the orbitals, I will discuss so many more examples. Okay. Shape of orbitals in this, the first one already we discussed, S orbital shape. What is the shape of S orbital? Spherical shape. S orbital, spherical shape. So like this. This is shape of S orbital. Okay. And next P orbital. What is the shape of P orbital? Dumbbell shape. P orbital shape is dumbbell shape, and P has S has only one orbital. That's why this is spherical shape. P has 3 orbitals, right? P has 3 orbitals. Okay. Px, Py, Pz. That means here I am drawing the P orbitals. This is Px orbital, dumbbell shape. This is Px and Py, Pz. And this is Py orbital, Py. This is Z and this is X. And one more I am drawing here. This is Pz orbital, X, Y, Z. ఒకవేళ ఇవన్నీ మొత్తం ఒక దగ్గర డ్రా చేసామనుకో, if you draw these all, this is Px orbital and Py orbital, and this one is Pz orbital. Px, Py, Pz. These orbitals only. These all are. This one is the Px orbital and Py orbital, and this is Pz orbital. Okay, this is the P orbital shape, that is the dumbbell shape. And next D orbital shape. D orbitals, that is a double dumbbell shape. Double dumbbell shape. D has how many orbitals? 5 orbitals. D has 5 orbitals. In this, the 5 orbitals, this one is dxy, and this is dyz, dxy, dyz, and this is dzx, and this one dx square minus y square, and this one we can call as dz square. Okay, I am drawing this one. First I am going to draw the dxy orbital. Here this is x-axis and y-axis. So this one is dxy. So the orbitals are lying between the axis here. This is dxy. And next to dyz. dyz. These are dyz. And next to dzx. Here this is z and here this is x. And next to dz square y square. Sorry, x square y square. dx square y square. So this is x axis and this one is y axis. The orbitals are lying on the axis. These three are between the axis and these two, this is what this one is lying on the axis. And next the final one dz square. dz square. Here. This is z axis. దీంట్లో ఇంకే ఉంటుంది అంటే ఇట్లుంటాయి. So this one is dz square. So draw this one firstly. This is px orbital and py orbital and pz orbital, this one. And this is total p orbitals. p orbitals. అట్లా మనకు total d orbitals ఒకటే దాంట్లో రాయలేము. And here dxy, dyz, dzx, dx square y square and dz square. I will give the important magnetic quantum number values. I am going to remove this one. Shall I? Okay. I next write down. You have to remember the important point. For s orbital, for s orbital, the m value, magnetic quantum number value 0 only, always. Yes or no? And for p orbital, there you have to remember p has how many orbitals? 3. Okay. No, 3 has p orbitals. In this, this one px and this one py and this one pz. Is it clear? The px value, now remember very important condition here. Always the pz value 0 amma. Always the pz value 0 according to nodal plane, we can call this one. According to nodal plane, that will I will explain after this next class. Nodal plane. అది ఎందుకు వచ్చిందనే నేను ఎప్పుడు ఒకసారి చెప్తాను నేను. So now you have to remember the pz value always 0. The magnetic quantum number, we are discussing about only magnetic quantum numbers. The pz value of magnetic quantum number 0. And the px value, the magnetic quantum number, -1 or +1. Okay, take it screenshot. Okay. Here the Pz value, the magnetic quantum number of Pz value always 0 and Px value -1 or +1. Obviously Py value also -1 or +1. అది ఎట్లా తీసుకోవాలని నేను ఎగ్జాంపుల్స్ లో చెప్తాను ఒకసారి. And one more for d orbitals. For d orbital, d has how many orbitals? D has 5 orbitals, right? D has 5 orbitals. In this first one we are assuming this is dxy and this is dyz and this one d zx and this one d x square minus y square and this one d z square. Okay. dxy dyz and next d 1 minute. Here this is dxy, this one dxy only, and here this is dyz and here this is dz square, the middle one always dz square, and this is dzx and this one d z square minus y square. Amma, remember here very important condition. Always the dz square value, magnetic quantum number for z square value is 0. Okay, na? If it is dxy -2, dyz -1 and dzx +1, x square minus y square +2. ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సిన ఇంపార్టెంట్ పాయింట్ ఏంటంటే dxy నాట్ ఓన్లీ -2, we can write +2 ఆల్సో. ఇవి రొటేట్ చేసుకోవచ్చు. And dxy yz and zx we can write +1 or -1. Amma will get the clarity. I will give example. Listen. For example, find the quantum numbers. 3 quantum numbers. That means principal quantum number, angular momentum quantum number, and magnetic quantum number for what I should say, sodium 10th electron. I am taking sodium 10th electron. 3 orbitals. Sodium 10th electron and 8th electron. And 8th electron. First, sodium 10th electron. I am going to find sodium 10th electron magnetic quantum. These are 3 quantum numbers values. So the sodium atomic number 11 electronic configuration 1s2, 2s2 and 2p6, 3s1. Okay. After filling electronic configuration, here it is 1s2 and here it is 2s2. And here it is 2p6, 1, 2, 3, 4, 5, 6, and here it is 1 only. So 10th electron will be in which orbital? Here 2 plus 2, 4, 5, 6, 7, 8, 9, 10. Actually, it contains 10th electron in this one only, right? So this one we are assuming px, py, pz. Okay, na? So that electrons are present in pz value. Now the principal quantum number value n is equal to, and angular momentum or azimuthal quantum number value and m value. Principal quantum number value. These electrons are present in second shell. That means n value 2. And this is p subshell. For p subshell, L value 1. And m, the electrons are present on pz orbital. What is the pz orbital value? The pz orbital value 0. Okay, this is for 10th electron. And one more for 8th electron. Okay, we have to find for 8th electron. 1, 2, 3, 4, 5, 6, 7, 8. 8th electron. 8th electron, this one. Okay. For this one, now we are going to write about the 8th electron quantum numbers. The principal quantum number for 8th electron, the n value 2. And the angular momentum quantum number 1. And magnetic quantum number. Ikkada py kada. So the py value -1 or +1. అంటే మీరు ఏం రాయొచ్చు అంటే ఎగ్జామ్ లో -1 ఆర్ +1 మనకి ఇచ్చే ఆప్షన్లలో ఉంటాయి ఇట్లా. ఓకేనా? -1 or +1. Okay, did you understand this one, everyone? And here you have to remember important points. In 10th class they did not give about the pz value with 0 and dz square value with 0. మనకు నార్మల్ స్టేట్ బోర్డ్ లో అయితే ఇది 0 అని లేదమ్మా, according to rules ప్రకారం ఉంది. But this is for experimentally, this pz value they got 0 and dz square value also they got 0. This is important for NEET, JEE mains and advanced. Okay, these conditions are you have to remember. Still any doubts? Anyone having doubts, or shall we discuss with one example? No need. If you have doubts, just inform me in chat box. Okay, I will explain with one more example. I am going to remove this one. In one more example, I will explain about zinc. Write the principal quantum number and azimuthal quantum number and magnetic quantum number values for zinc last electron. Try to write this one. The zinc atomic number 30, its electronic configuration 1s2, 2s2, 3s2, 3p6, 4s2, 3d10. 1s2, 2s2, here 2p6 amma. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Total 30 electrons. So the last electron will be in 3d only. Try to write quantum numbers. This is dxy, dyz, dzx, dx square y square, and dz square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is last electron, right? For this electron, we have to write quantum numbers. 3 quantum numbers for this electron. Okay, write this one. The principal quantum number, azimuthal quantum number, and magnetic quantum number. Okay. No one are giving answer. Are you understand the question first? For this electron, we have to write the 4 quantum numbers. These electrons are present on which shell? N is equal to 3. What about the L value and M value? L is equal to 2. What about the M value? Somewhere they are wrong. Magnetic quantum number values are important. M is equal to -2. Vaibhav Surya. SSV Krishna, very good. Only one person said the answer. The M value is 0. Here the magnetic, actually the principal quantum number value 3, N is equal to 3. For D subshell, L value 2, very good. But when comes to M value, I told already always D square value is 0. Okay. Did you understand? Okay. And one more question I am giving. Just try to do this one. Okay. Simple question number. Calculate the value of N, L and M for 7py orbital. 7py orbital. Do this one fastly. 7py orbital. Calculate the value of N, L and M for 7py orbital. 7py means their N value. What is the N value and L value and M value? P orbital is nothing but Px, Py, Pz. We know already the Pz value is 0. Now based on this, write the answer. Do it faster. For this simple question, you are taking time. Why I did not understand. For N is equal to 2. Mukta Malyada wrong. Vaibhav Surya, N is equal to 2. Total values write down now. What about the M value there? M value? Right. Okay. M value, how you got 0? Latika? Actually, listen here. The N value 7th only. The N value 7. Why? Because it is the 7th shell. And for P subshell, always the P subshell L value 1. And these electrons are present on Py. Py ante. This is, it may be +1 or -1. ఒక్క PZ మాత్రమే 0 తీసుకుంటామమ్మా. Remaining we can write here +1 or -1. Okay. I hope everyone understood. Shall I remove this? We are going to discuss about the one more quantum number, the final one. The last quantum number, the fourth one is spin quantum number, which is very easy. Spin quantum number. Spin quantum number. Write down the points given by this spin quantum number given by Gauss-Smith and Uhlenbeck. The spin quantum number given by Gauss-Smith and Uhlenbeck. It represents the direction of electron spin around its own axis, and for clockwise, and that means here, which is very easy. Actually, the electrons are revolving around the nucleus. These electrons are revolving around the nucleus. The electrons, it may be revolves. One is clockwise direction and other one is anti-clockwise direction. That means this is the orbital. In orbital, the electron one will rotate in the clockwise and other will be rotate in the anti-clockwise. So this half is nothing but clockwise direction and this downward arrow is nothing but anti-clockwise direction. This electron will rotate in the clockwise and this electron will rotate in the anti-clockwise in the atom. So for a clockwise spin, here next point, for a clockwise spin, clockwise spin is nothing but upward direction. Spin electron, we can represent plus half. For anti-clockwise spin, minus half. For anti-clockwise spin, downward electron, that is minus half. And that means here, for example, this is a orbital. In this orbital, the first electron will be clockwise and other electron will be anti-clockwise. So this electron we can represent as plus half and this electron will represent it as minus half. Okay, plus half, minus half. That means clockwise direction, anti-clockwise direction. Okay, na? So in an orbital, it is not possible to same direction of two electrons. Okay. So this rule was explained by the Pauli's exclusion principle that we'll discuss later. Copy here up to remaining class we'll discuss on Monday. It will be complete within 2 classes. Then next we will discuss about the electrochemistry.